Hey guys, Joe back at it once again with some OCR FSMQ past papers, and today we are doing the June 2009 examination paper. Now, if you've missed the June 2007 and June 2008 papers, they are on a playlist which are on the channel, and the learning objective is of course to analyse a past paper and see how we would do, and we'll be doing all of the papers up to 2015. So question 1. The angle theta is greater than 90 degrees and less than 360 degrees, and cos theta equals 2/3. Find the exact value of tan theta. Well, what you do here is draw yourself a nice little right angle triangle. We know cos theta equals 2/3, so that means our adjacent is 2 and our hypotenuse is 3, and that's essentially because a cos in its purest sense is an adjacent over a hypotenuse. So the 2's playing the role of the adjacent and 3's playing the role of the hypotenuse, as shown there. So through Pythagoras now, we obviously get the root of 3 squared minus 2 squared, and that equals root 5. Right then, a tan theta is an opposite over adjacent, so the exact value must be root 5 over 2. Now that is an exact value. We don't need any calculator values in this question. Most students would just write the full calculator display, but the exact value is root 5 over 2. Question 2. Find the equation of the normal to the curve y equals x cubed plus 5x minus 7 at the point 1 minus 1. So there's the name of your curve. And how do you find the gradient of the curve? Well, you differentiate it with respect to x. 3x squared plus 5. Shove your x coordinate through and you get dy dx equals 8. But that's the gradient of the tangent. We want the gradient of the normal. So we need to reciprocate it and swap its sign, because we need the negative reciprocal, remember, for normals, because they meet tangents at 90 degrees, so the perpendicular. So our gradient is therefore minus an eighth. Y minus b equals mx minus a. Put in the numbers. Be very careful of double negatives. Times everything by 8 because I don't like fractions, and times throughout. And then make everybody positive, and you get 8y plus x plus 7 equals 0. But any acceptable form after that point there is absolutely fine. Question 3 then. A is the point 1,5 and C is the point 3p. Find the equation of the line through A which is parallel to the line 2x plus 5 equals 7. So there's the name of a line, but remember, to work out the gradient of that line, we need it in a very specific format. We need y equals mx plus c. So we're going to have to move that x over the other side to get that. And now we need one singular y, so what do? We divide by 5, both sides. So you get 7/5 minus 2/5 of x. So our gradient is therefore minus 2/5. And remember, parallel lines have the same gradient. So y minus b equals mx minus a. Just pick a point. It goes through A, so we're told to use this point here, 1,5. And you put in the numbers, times throughout by 5, and you get that. Take people over the other side, and you get that. But any acceptable form, yet again, after that point, is absolutely fine. So this line also passes through the point C. Find the value of P. Well, the way you test if a point is on a line is by letting the coordinate play the roles in the line. So P's playing the role of a y, and the 3's playing the role of an x. So by that logic, 5p equals 21. So therefore p equals 21 over 5. Not too bad a question, that one, for number 3. Question 4. AB is the diameter of a circle where A is 1, 1 and B is 5, 3. So find the exact length of AB. Well, length equals back take back squared, added to front take front squared, and rooted. So you get that. Put in the numbers, and you get that. So L is root 20, or if you cancel that down, it's 2 root 5. And that is the exact length of AB. Exact means leave it in third form. We don't want decimal answers. We want exact numbers, which means you must use keep it in third form. So the second part, the coordinates of the midpoint of A, well, it's just the average of the x's, the average of the y's. So you get that, 3, 2. Nothing really difficult about that. But now we want the equation of the circle. So we've got the centre point of the diameter, which must be, by definition, the centre of the circle. And we've also got a diameter. But the equation of a circle is that. So we need R instead of D. So we're going to have to half that answer. And you get that. So remember, you reverse the sign of the circle centre and dump it in like that and like that. And it's root 5 squared. If you times a third by itself, it just pops out the number and you get 5 on the end. So it's x minus 3 squared add y minus 2 squared equals 5. Easy peasy. Number 5, parcels slide down a ramp. Due to resistance, the deceleration is 0.25. One parcel is given an initial velocity of 2 meters per second. So find the distance travelled before the parcel comes to rest. So list your variables at SUVA, it's constant deceleration. So you're absolutely fine to use SUVA. So there you go, you put that along the top. Then you read the question and you say, well, I've been told my initial speed of 2. I've been told that it comes to rest eventually, and I know my acceleration is minus 0.25. Remember, a deceleration is a negative acceleration, so don't put 0.25, put minus 0.25. So be very careful on those ones. But we need an S for the first parcel because it's asking for the distance. So we apply the formula. V squared equals U squared plus 2AS. We substitute the numbers in. And you get that. And to get S on its own, we take the 4 over the other side and divide by minus 0.5. So you get 8 meters overall, because it's going to be minus 4 over minus 0.5, which is going to make it a positive 8 meters. Right, a second parcel is given an initial velocity of 3 meters per second, and it takes 4 seconds to reach the bottom of the ramp. Find the length of the ramp. So we need an S for the second parcel now. So we apply the formula, and we say S equals ut plus a half at squared. Substitute the numbers in. We want an S, we know 4 seconds and 3 for the initial, so 3 times 4 is 12. Add a half times same deceleration, minus 0.25, times 16, which is ut squared, which is 4 squared, which is 16. And you get that. 10 meters, nice answer. So, not too many issues if you know your SUVAT in and out there. 6 marks, not too bad. Question 6. The gradient function of a curve is given by dy dx equals 1 minus 4x plus 3x squared. Find the equation of the curve given that it passes through the point 26. Well, to get from dy dx to the name of a curve, we must do the opposite of differentiation, which is integration. So we integrate that curve with respect to x. And remember, we integrate by adding 1 to the power, dividing by the new power. So we get that. But remember, don't forget your c, because there'll have been a constant there. That's a very bad rubbing out, so I'm going to get rid of that if I can. There we go. There we go. Oh, I thought I had my pen there. There you go. So there's your c. Right, 3 over 3 is obviously 1, so you can just cancel those like that. A 4 over 2 is just a 2, so we stick a 2 there, which is that. And now we're told some information about the question. So if we set this equal to y now, and we set that y equal to 6 and every x equal to 2, we'll get that, plus c, and now we can filter out with c. So c is a 4, and the last stage is to put that 4 back into your equation, which is up here, and tell the examiner that's y equals x cubed minus 2x squared plus x plus 4. Now somebody actually wrote me a personal message and asked about the use of c in a later question, which we'll talk about in a second. But for this one you must have a c. So number 7, the course of a cross-country race is in the shape of a triangle ABC. AB equals 8, BC equals 3, and angle ABC is 60. So that's shown on the diagram here. Calculate the distance AC and hence the total length of the course. So it's a cosine rule because we've got the old scissor action here right there. So you got an angle trapped between two sides. So A squared equals B squared plus C squared minus 2BC cos A. You're given that in the exam. So you dump in the numbers. Cos 60 is a half if you're interested. So that means that 2 dies and that dies. So you're going to get 9 add 64 minus 24. So you get A squared equals 49. That puts a huge smile on your face because therefore A is 7. So now I know that is 7. But a lot of people will have dropped a mark because they'll have forgot this bit. The total length of the course is therefore not something I did. So it's 8 add 3 add 7, which equals 18 kilometers. But it's the sine rule for this bit, so calculate the angle BCA. BCA is this angle here, so we've got the opposite buddy angle and its opposite buddy, and the same there. So sine rule, put in the numbers, rearrange, put in your calculator, A equals 50.3 degrees. Question A. Calculate the x-coordinates of the point of intersection of the line y equals 2x plus 11 and the curve y equals x squared minus x plus 5. Give your answers correct to 2 decimal places. So y equals that and y equals that. So if I see a y here, I can paste it into there. So that 2x plus 11 can play the role of y in this one. So that's what I do. Or opposite way around, really doesn't matter. Then I'm going to rearrange, make a nice quadratic set equal to 0, and I said in the last episode 99% of the time it'll factorise. This is the 1% where it doesn't, so we have to turn to the quadratic equation, which you must learn. And obviously because that's a minus 3, that becomes a plus 3 there, because the quadratic equation is minus b plus or minus the square root of b squared minus 4ac all over 2a. And put in the numbers and you get 4.37 or minus 1.37, and luckily we're only asked to work out the x coordinates, and you know it's going to be nasty because it says to 2 decimal places. Question 9. A car accelerates from rest. At time t seconds, its acceleration is given by a equals 4 minus 0.2t until t equals 20. So for the first part, find the velocity after 5 seconds. So if you remember, the relationship between acceleration and velocity is via integration. So we're going to have to integrate a with respect to t, which is 4t minus 0.2 t squared over 2, and you would have a plus c here, but you were told that when t equals 0, because it says a car accelerates from rest, so that means when t equals 0, v equals 0, so that means that that would die and that would die, so therefore c would equal 0 as well, so we can just forget about them. So there you go, v equals 4t minus 0.1 t squared. Right then, what is happening to the velocity at t equals 20? Well, most people would have said, well, they'd have put t equal to 20 in the v equation, say it's travelling at whatever meters per second, which is, what am I doing here? Oh yeah, I haven't finished the part 1 here. So you put a 5 in for a t to find out what velocity it's travelling at. So when t equals 5, v equals 17.5 meters per second. So that's that. When t equals 20, a equals 0, therefore it's at its maximum speed, because if you think about it, if you accelerate no more, you must be at your top speed, which means it's a maximum velocity. It could also mean a minimum velocity, but if you let t equal 20 in this equation here, it would most likely be higher than 17.5. So that's how that works. Part C, find the distance travelled in the first 20 seconds. Well, you integrate between limits because it's the first 20 seconds, so it's 20 to 0. Integrate v with respect to dt, and you get your displacement. So add 1 to the power, divide by the new power, using this equation here. Quite a lot to take in on this question actually. Put your 20 in, put your 0 in, take them off each other, and you get about 533 meters, which is quite a nice answer. So that's question 9 done, and rightfully 7 marks, I'd say. Question 10. Illustrate on one graph the following 3 inequalities. Now, I'm literally just going to do that and that. Y equals 2. This is the easiest question on the paper. If you know how to draw inequalities on graphs, and it's just like drawing lines on, y equals x minus 1, so that's this line here, I believe. And then if I want to be above the line, I shade below. X is greater than or equal to minus 2, that's this line here. And I want to be bigger than 2, so I shade this side. And the other one, 2x plus y is greater than or equal to 8. Using the cover-up method, you get 2x equals 8, x equals 4. So you put a cross there. Using the cover-up method again, you get y is equal to 8, so you put a cross there. Join them up, oops, and then if I want to be greater than, I shade beneath, and then it's asking for the minimum point, which is blatantly there, so you just say y equals 2. So they're the easiest 5 marks on the paper, I would say, if you know how to draw graphs. Question 11. The shape ABCD represents a leaf. The curve ABC has the equation that, and the curve ADC has the equation that. So find algebraically the coordinates of A and C, the points where the curves intersect. So remember, if I see a y here, I can paste it in for this y here. So that is equal to that, which is shown there. Take people over the other side. I see a common factor of 2 there, so I just call it that. Now solve that. This one does factorize, so you get that. So your x is 5 or x equals 2. Y equals 6 or 3. So there are your points there, 5, 6 and 2, 3. Find the area of the leaf. Well, if you know where these meet, you now know the goalposts that you put up. So put up with goalposts like that. So it's the area between 2 and 5 of the ceiling to the floor. Now the way to tell it's the ceiling is because it's an upside down x squared graph, which means it's had this negative on the front of it. Negative x squared graphs look like n's, positive x squared graphs look like u's. So ceiling take floor is that minus that. Careful with double negatives, and you get that. So we're integrating that with respect to x between the limits of 5 and 2, which is that. Add 1 to the power, divide by the new power, and you get that. Between 5 and 2, stick your 5 in, stick your 2 in, and you get that. For some reason that says 1, it should say 2. Take them off each other, and you get 9 units squared. Remember units squared because it's area. But quite a tricky 12 marks there, but if you know how to do it, you'll be fine on the exam. Question 12 then. The diagram shows a rectangle ABEF on a plane hillside which slopes at an angle of 30 degrees to the horizontal. ABCD is a horizontal rectangle. E and F are 100 meters vertically above C and D respectively. AB equals DC, FE equals 500. So all of them are equal to 500. AE is a straight path. From B there's a straight path which runs at right angles to AE meeting at G. So part 1, find the distance BE. So that is this distance here, and that is nice and easy. Soccer tour, which is BE is opposite over your sin, so it's going to be 100 over sin 30. Sin 30 is a half, so I just double it and call it 200. So that's part 1 done. II. Find the angle that the path AE makes with the horizontal. So AE is this line here, all the way up. This is very, very bad of me. And I'm just going to get rid of that there. And this is the angle you want here. So we're going to call that X. Right. Well then, we're just going to say Pythagoras because we want the length of it, and then we can do SOHCAHTOA again. So AE squared equals 500 squared add 200 squared. AE squared equals 290,000. So AE must be 538.8. There's the 500, and the 200 I just worked out is the BE. Sin A equals opposite over hypotenuse, so it's 100 over 538.5. So A equals 10.7 degrees. So that there is 10.7. Find the area of the triangle ABE. So ABE is there to there to there to there, like that. So area of a triangle, half the base times the height, half times 500 times 200, 50,000 meters squared. So really not a bad question. But this is the interesting bit, hence find the length BG. Now I actually forgot to do this on the PowerPoint, but as I was reading through before, it was just something I looked at. But they do it in a way where you use the area to work out the length BG. Now, the way I did it, and the way I suspect most people did it, is because we know the angle there. We just did it through Pythagoras. We've got the adjacent here. Is it an adjacent? No, it's not the adjacent. Sorry, it's the hypotenuse. Got a right angle there. So that's a hypotenuse. We want the opposite. So it's simply going to be sin 10.7 times 500. And I believe that equals 186.4 or something similar. So if I do that on my calculator very quickly now, so sin 10.7 times 500, and it equals 92.8 actually. So that's not right. Hold on a second. Is that's the adjacent? BG is that. That's the hypotenuse. Yeah, it's a question that's actually bamboozled me. I'm not sure how you solve it. So this is me stumped. I would have lost at least 3 marks on the exam. So a big deal. Don't worry too much about it. But you are meant to get 186 or something similar to that. Funnily enough, if I times my answer by 2, it doesn't matter. I wouldn't worry about that question too much. It's 3 marks on the exam. Go and search it up if you want. I'm really not sure how to solve it, so you guys are better than me if you can do it. Question 13. In a supermarket chain, there are a large number of employees, of whom 40% are male. One employee is chosen to undergo training. What assumption is made if 0.4 is to be taken as the probability that the employee is male? There's a random selection. That is the only thing that you can say for that one. That's 1 mark. 6 employees are chosen at random to undergo training. Show that the P of all 6 chosen are female is that correct to 4 decimal places. So x can be binomially distributed as 6, 0.6, because if it's 0.4 for male, it must be 0.6 for female. P of x equals 6 is 6c6 times 0.6 to the 6 times failure to the rest. So you get that. If you type that in on your calculator, you will get what the examiner wants you to get. Now then, find the probability that 3 are male and 3 are female. So that is simply just the P of x equals 3. 6c3 times 0.6 to the 3 times 0.4 to the 3. And that equals 0.276. For 4 marks, that is not bad at all. Now then, this is the interesting one. There are more females than males chosen. That's the P of x is greater than 3. So that's just 4, add 5, add 6, which is that, add that, which is 0.544. So not the worst binomial question by any means, and that is a nice 12 marks in the bag if you know it. Question 14 then. This is just a silly little question. I really disliked this paper, I'll be honest with you. On the same graph, draw sketches of the curve y equals x cubed and the line y equals 3x minus 2x. That's just that. And part II, use your sketch to explain why that only has one root and there's only one intersection point. So B, show by differentiation that there are no stationary points to that curve. So you do y dx it, and x squared equals minus 1, therefore no solution, because obviously you can't square root a number and get a negative answer. So that's that. Really wishy-washy question. I really don't like it. Hence explain why the equation x cubed has only one root, because the curve is always increasing and it can only cross the x-axis in one point, which is the root, which is fair enough. And you can see that by this, well, it's actually not the same cubic, I'm telling a lie here. It's just a very wishy-washy question. I haven't seen anything else on here to do with that. Use the factor theorem to find an integer root of the equation, where you just throw some numbers in it and hope that you get it equal to 0. I chose 2, and therefore x minus 2 is a factor because it equals 0 when you put a 2 through. Write down the equation in the form that, so you want to divide x minus 2 into the cubic, and you'll get that. You'll get that as a quadratic on the top, and then you can factorize. No, it doesn't want you to go any further. So by considering the quadratic equation that found in part II, show that the cubic equation only has one root. There's no solutions to that quadratic, so x equals 2 is the only root. They have an obsession with only one root here. So you were given that R and S are positive numbers. What do the results in A, B and C suggest about the equation that? Well, that'll only have one root. that is their obsession with the question, and funnily enough, that is the answer to the question. It'll only have one root for all R and all S. So that is that, guys. Apologies about the last question there. It's a very wishy-washy one. I really don't like it, and not being able to find out the solution to the length of BG. Obviously, if I do find a solution to that, I will put it online. But check out the FSMQ website. They do have a mark scheme, but I kind of get my head around what they're actually doing in the mark scheme. There's probably other channels that talk about it, but yeah, bamboozled me. So I hope you guys found this paper helpful. Please leave a like down below if you did. Leave your feedback down in the comments. Tell us the answer to that question if you want to. Try and explain it to us. But you guys are better than me if you can get it. And yeah, check out the other videos of OCR on the channel, and in 3 days' time you'll see the June 2010 paper. So I hope you guys are having a wonderful day. Thanks for watching, and goodbye.